Hi, everyone, and welcome back to the Career Catalyst, the podcast where we explore life behind the titles and dive into the stories, insights, and experiences of professionals shaping the world of healthcare and medicine. I'm your host, Maya, and this month we're exploring careers in pharmacology and biopharmaceutical sciences, fields where chemistry, biology, and medicine intersect to create real treatments that change lives. Today's guest has spent decades working on that intersection, both in industry and academia. Joining us today is Dr. William Ogilvie, a retired professor and former director of the program in Biopharmaceutical Science here at the University of Ottawa. Over the course of his career, Dr. Ogilvie has worked in both academic research and the pharmaceutical industry and has contributed extensively to teaching, mentorship, and chemical research. In this conversation, we'll talk about his academic and professional journey, how organic chemistry connects to real-world medicine, what careers in biopharmaceutical science actually look like, and what students should keep in mind as they navigate their own paths in science and healthcare. Thank you so much for being here, Dr. Ogilvie. We're very honored to have you on the podcast.
Thank you very much for having me.
To start off, could you tell us a little bit about yourself and what your work has focused on over the years?
My work, I guess, focused on organic chemistry. So when I was an undergraduate student, I managed to get a job in the summer working in a lab doing organic kind of stuff, and I really enjoyed doing that. And then since then, that's basically what the focus of my stuff has been. After I did my bachelor's degree, I did a PhD in synthetic organic chemistry, basically learning how to make things and inventing new ways to make things. I then did a postdoc down in the US, two different places, the University of Pennsylvania and Scripps Research Institute, which was in San Diego. My original plan was to be a professor, but that didn't work out right from the start. I ended up going to a pharmaceutical company where I worked developing antiviral medications for about 11 years, I think. And then I switched gears and went to the University of Ottawa, and I was there 20-something years. And almost 2 years ago now, I decided to retire. And it's been started out a focus on organic chem. I went into drug development, then I kind of came back to organic, and then finally I finished out my career more in chemical education, I would say, than anything else.
That's a very non-linear path, I would say, and congrats on your retirement.
Thank you.
I hope you're enjoying your time.
It is fun.
That's good. Good to hear. As we just heard, you've had a career spanning industry, research institutes, and then eventually academia. And I wanted to follow up on that. What were the key steps or turning points that led you to where you are now?
Oh boy. I'd say kind of at each point I had a little bit of an unexpected sideways movement. Did my PhD, and that was all kind of straightforward. And then when I did my postdoc, that was all kind of straightforward, and that was the path that I thought I was going to be going on. Usually, when you do a PhD in science, you can go directly into a job. Usually, it's going to be in industry. But if you want to work in academia, if you want to be a professor, you have to do something called a postdoc, which is kind of like an internship that you do, usually for about 2 years, sometimes longer, sometimes shorter, after you do your PhD. So that was my initial thing I thought I was going to do, and so that's why I did the postdoc. Now, it turned out that when it was time to look for a job at a university, I was wanting to come back to Canada. I didn't want to go outside the country. And at that time, there was only 2 job openings. And turns out I got an offer for one of them, and I didn't get the offer for the other. But my wife didn't want to go to the place that gave me the offer. And so I kind of had to switch to plan B and decided I could have done an extra year of postdoc, but I didn't really want to do it. And so instead, I applied to a pharmaceutical company and ended up going there. The funny thing, I didn't even know the company existed before I sent an application. I just sent letters everywhere. And it turned out that these guys got back to me, and I got really lucky. I ended up working for what I would say is a really top quality company. A lot of good people there. I really enjoyed the research that I did when I was there. The company was nice to us. It was kind of a great experience. But after being there 11 years for different reasons, I decided I wanted to change jobs. Initially, I thought I was just going to go to another company, but I happened to make a phone call to the right guy, the right place on the right day. And I found out that U of Ottawa was looking for somebody to teach medicinal chemistry. And so I applied for that and somehow conned them into hiring me and ended up switching jobs now to academia, which was kind of I got to say, it was a really scary experience. But overall, I'm really glad I made the switch. In the university, I started out doing research, and I would say for the first 10 years that I was at U of Ottawa, I had a research group and was actively doing research. But I got to a point where I wasn't enjoying it anymore. And so I switched out and kind of went more to chem ed and got into writing books. And so kind of did another little sideways thing. And yeah, so here we are. I actually ended up doing actually one more thing that was kind of, I guess, a sideways career path as I retired early.
What was it?
Um, hey,
If you don't mind telling us, what was it?
COVID. So um, normally, I don't know if you'd notice, but professors usually don't like to retire at 65. You kind of get to be successful in research, especially, you have to become a bit of a workaholic. And I think people have trouble to retire at 65. I actually retired when I was 62. And a big reason for that was COVID. It just kind of, the online stuff sucked all the fun out of it. And so decided to retire early. And so here I am talking to you. I'm down in Miami right now. So, just doing things differently.
It's very interesting how, as you've walked us through your whole journey, things work out in very unexpected ways.
Yeah.
And as you said, if you can make a call, and if it's the right time and the right place, it just works out in an unexpected way.
Yep.
But it eventually becomes a very valuable experience.
Well, no, that's very true. I mean, a lot of life is being ready to take advantage of opportunities when they come your way. So, I know students freak out. Am I going to get a job after? Am I going to, what's going to happen to me?
That's right.
The thing is to be prepared and to be open-minded. And if you're prepared, you study well, you learn you know what you're doing. You create, you make yourself able to take advantage of those opportunities when they come your way. And it's amazing how these things just come randomly, being at the right place at the right time. And I have lots of friends and colleagues and former students that have been like that. They just kind of fell into a job by being at the right place and the right time and being prepared to take advantage of it, but also being kind of a little bit open-minded. Sometimes, I know changing jobs for me was really scary. Working at industry was really scary. Leaving that and going to academia was really scary, but things work out. You gotta be willing to take advantage of those opportunities.
Yeah, I guess you just gotta be prepared, put yourself out there,
Yeah,
and just jump into whatever comes your way and see how
go
things
for it.
work out.
That's the thing too. You don't know how it's going to work out
Yeah,
until you actually do it.
that's right.
And I found, in making different kinds of career transitions and different changes, when you go into it, you're always, oh no, can I actually do this or not? But what I've discovered is you don't really know until you do it. You don't know what a job is about until you've actually done that job. And so, I guess the lesson is just do it, and that's how you find out.
Yeah, you can't know it unless you try it.
No.
Every field has its own challenges that shape how we grow. What are some realizations or challenges that influenced how you've approached research or teaching?
Um, in terms of research, I'd say the biggest challenge to that is to kind of stick with it. Research can be really rewarding when things go right, and it can be really demoralizing when things go wrong. And so you have to really stick with it, and you got to want to do it. To be a researcher, I'd say you have to enjoy doing it, because you have to be a little bit of a workaholic, I would say, in order to be successful at it. So, keeping up with that, and being generally interested in it. The other thing that I found when I was doing research, and I'd say especially this was when I was in industry, uh, not as much in academia, but it's still there. And that is one thing I didn't expect was that I was going to have to manage people. And so I had employees reporting to me. When I was doing research, I had students that I had to kind of guide along the way. And so you have this, you're trying to manage people. And as a scientist, nobody ever tells you how to do that. You go through your career and they're telling you all the science that you need to know, but managing people needs some people skills, and they don't tell you that. Um, Something I had to kind of learn the hard way along the way. I also learned a little bit by taking some management courses when I was in industry. And in fact, a number of years ago, we created a program where science graduate students could do some management courses from the Telfer School. In fact, it focused on kind of people skills, conflict management, that kind of thing. For myself, I'd say that was the most difficult thing in research was to managing other people. It wasn't something I'd ever been trained for, and to be honest with you, wasn't something I enjoyed a lot. When things were going well, it was great. I'm not the type of person that likes to discipline other people, and I kind of didn't like that aspect to it. In terms of teaching, the big realization that I went through when I started teaching was to think back on what it was like when I was a student. And I tried to think of the three or four really good professors that I had, and I tried to do what they did. I also tried to think of the three or four worst professors that I had, and I tried not to do what they did. And as going through, you going through the teaching experience, I really, from time to time, in fact, on a regular basis, would kind of stop and think, am I doing this in the way that, the good guys used to do it, or am I making the mistakes that the not so good guys would do? And really try to think of it from, a student's perspective. One thing I've noticed from professors, I mean, how do I say, we were always the kid that was at the top of the class. And then you have to teach and you have to explain things that to you are kind of simple, but to other people, they have, quantum, whatever. I mean, it's really confusing and scary and new. And to alter your thinking to try to explain that to somebody in a way where you know that they have no idea what you're talking about. That's a challenge, and I think that was one of the biggest challenge I think for teaching. The influence, like I said, I just used old mentors or older teachers as a role model, and went that way.
That's nice. That's very nice to hear, especially as we were saying earlier that, when experiences and opportunities come your way, you wouldn't know what it's going to look like until you're in it. And then once you're in it, you learn a lot of stuff about yourself that you hadn't known
Yeah,
before.
yeah,
And regarding teaching, when you mentioned that you tried to do it the way that your good professors did, you would try to be like them and avoid being like the bad professors, so
yeah,
to speak. Like I heard a saying that if you question yourself and like you want to do it well and all that, it's very likely that you're doing it well. And yeah, and it's very, very nice to hear that there's a lot of things that we kind of don't know about ourselves that we kind of realize later,
Yep.
you know? And
Yep.
yeah.
Well, that's an interesting point you raise, in that one of the things I've learned over the years is that from time to time you really got to swallow your pride and say, okay, I've just gotten some feedback from blah blah blah, and the way I've been doing it maybe isn't the best, and I should do it this way. And admitting that to yourself can be difficult
I know.
sometimes.
Yes.
And I've tried, when I was kind of active, well, as a teaching courses, I've always tried to, listen to feedback and to make changes to improve things. So, and that's not always easy to do.
That's right.
There's another aspect to that, and this was more, I'd say, relevant to when I used to work in industry. But sometimes it's difficult to be honest with yourself about what you really like and what you really want to do.
Hmm.
For example, when I was in industry, we were pretty competitive, a lot of type A personalities working at this place. And so we're competitive about getting promoted and who's going to be the next director and who's going to be the next group leader and all of this kind of stuff. And I learned from some of the other people that I worked with that, you want to be honest with yourself. Do you really want to be the group leader? Do you really want to be the guy that's, in charge of 50 people? I mean, some people would certainly like that. For me, learning that I didn't really want to be in charge of 50 people, uh, again, that's kind of a difficult thing to admit to yourself, because all these years you said, oh, you got to do this, you got to do that. Being honest with yourself is difficult sometimes, but if you can do it, it's important. It leads to kind of happier existence.
Hmm. Yeah, and I always think of it that way, and I also say to myself, ego and pride is always, it ruins everything, relationships, your place in, society and all that. And if you just put it aside, if we just put our pride and ego aside, then we're gonna be able to do so much better stuff, and it's, yeah, as you said, it's very, very difficult, but it's very, very
Oh
important.
yeah,
It's very important.
yeah,
Yeah.
yeah. I agree with you 100%.
Hmm.
It's you need a certain ego to get through, because that kind of gives you confidence, but you got to know when you're wrong.
That's right. You gotta admit it.
Yep.
Yeah. Okay, so your research focuses on asymmetric catalysis and organocatalysis. For students who may not be that deep into chemistry yet, how would you explain why this work matters?
Well, for if you've done any kind of organic chemistry, one of the basic things that we teach is chirality, where you have mirror images that are different from each other. And the example we use are our hands. We have a right hand, we have a left hand. Our hands are mirror images of each other, but they're different. Try to put a right hand into a left glove, and you know exactly that, a left and a right and a left hand are not the same thing. Well, molecules have that same kind of property, that you have right-handed and left-handed molecules. And as it happens, the molecules that are used to construct us all have that property. And so when you want to make anything that's going to interact in a human body, like for example, some kind of pharmaceutical or a vaccine or whatever, you've got to realize that those molecules that you're making are going to have to interact with the biological molecules in your body. Those biological molecules have a handedness to them, we say right hand or left hand. And so there's many, many drugs that also are handed. They're right-handed or left-handed, so they can fit correctly. And it turns out that one of the biggest challenges in doing organic chemistry is controlling the right-handedness, left-handedness. And so these days, this what we call asymmetric synthesis or asymmetric chemistry is all about, how do you control right hand, left hand? And it's pretty fundamental to pharmaceuticals. It's actually also part now of things like material science and some of the really high-tech materials. Uh, it's they use different terms, but it's related to that idea of asymmetry. So it's key really for modern. If you work in anything pharmaceutical related, material science related, it's a really important property. It's very difficult to do, and so that's why you have this heavy duty focus on it.
I see. That makes a lot of sense, actually. And it's very interesting. I did not know that molecules in chemistry are like that too. You know, there are asymmetry and then they may fit
Mhm.
together, may not fit, and all that. This is very, very interesting to hear. I've never heard that
Yeah,
before.
there you go. It's amazing how much of living things are one molecule fitting into another molecule. You can distill a lot of biochemistry down into that. You can distill a lot of pharmacology, all kinds of things. It's just molecule A has to somehow fit with molecule B.
Yeah, it's very interesting. And as a science student, I find that super interesting and super intriguing.
Ah, very cool.
Yeah.
It's
Um,
good to hear.
a lot of students struggle with mechanisms in organic chemistry, including myself. And from your perspective, why is mechanistic thinking so foundational to drug development, and where do things usually go wrong?
Okay. Let me answer the first part, and then I got to clarify what you want for the second part.
Okay.
The mechanistic idea comes in a couple of different ways. So, when you are designing a drug, you have to kind of from scratch design a molecule. Now, the thing about molecules is that they have what are called functional groups. They're kind of all attached together. And the way that these functional groups interact kind of determines the properties of that molecule. Now, sometimes the functional groups cooperate and sometimes they don't. And if you're wanting, for example, to make a drug, I could design a drug on paper, but that drug may not be possible to exist because the different groups that I have designed on that molecule aren't going to play nice. And so if I put them all together, it's going to basically all fall apart. And so when you're designing these kind of pharmaceutical things, you need to, at least on paper, so you don't waste a lot of time, making something that's impossible. You have to be able to sit down and say, okay, is it reasonable that if I build this thing, is it going to hold together or is it going to just fall apart? And the way that you do that is functional group A and functional group B, the way that they interact is they exchange electrons with each other. And that's what mechanisms are. It's basically looking at how the electrons move around in a molecule. So if I'm designing a drug on my desk on a piece of paper, I'm going to write it out, and then I'm going to spend a little time figuring out, if I attach this group here and that group there, are they going to want to exchange electrons super easily, or are they, will they behave? And so mechanisms become a key part of that, just to determine, what can possibly exist and what can't. The other key thing that mechanisms are part of is that, okay, let's say I design this thing and I want to go to the lab and build it. Um, I can't, the way that we do chemical reactions is not like Lego where you just attach one block after another. Sometimes we put things on and then we have to take them off, and, there's an order to how you do things. And you have to do it in such a way that when you mix those chemicals together, that they actually do what you want them to do. If I do things in the wrong order, it's not going to work the way I want it to work. And so the way that you determine the order in which you should do stuff comes down to these functional groups. Is this group going to play nice with this group? And the way that you know that, you can draw that on a piece of paper, use a mechanism to figure out if I do this to functional group A, what's going to happen to functional group B, and that's why they're important. The other part of that that's important is that you can think of organic chemistry kind of operates like mathematics. So mathematics, you got numbers 1, 2, 3, 4, 5. Think of in organic chemistry, think of things like atoms or functional groups as being numbers 1, 2, 3, 4, 5. Now, how do I go about in mathematics, we have operations, addition, subtraction, multiplication. In organic chemistry, or in chemistry in general, we have mechanisms. How does this go where there? There's two ways to study organic chem. The old way is you study the functional groups and you memorize all the stuff that they do. And to me, that's kind of like studying math, where I'll study the number 5 and all the things that happen with the number 5. And then when I'm done, I'm going to start at the number 6 and look at all the things that happen with number 6. And then I'm going to look at number 7 and 6,
It's
7.
just a lot.
Yeah.
Yeah.
Math, it's much better to study the operations. If I do addition, once I know how addition works, I can add any two numbers. Mechanisms are like that. Once you know how mechanisms work, then you don't need to know everything about a given functional group. You can figure it out, because it's like learning addition, subtraction, division, rather than just memorizing the numbers. That's why I would say they're important. You asked the second part about things going wrong. What was?
I was just saying that, and I think you kind of mentioned it briefly, that, how do things usually go wrong in processes like that, which is like when they don't fit or overlap together and all that, right? Or is there anything you want to add?
It can happen that way too.
Yeah.
The other thing that happens is just you can't think of everything.
Okay.
And so you make some plan that you're going to engineer this molecule, blah, 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 and you can make your best predictions, but you're never going to know until you actually try to go and do it. And when you go to do it, I mean, human beings being human beings, we figure out, this isn't working because I've got the wrong solvent, or, this isn't working because Group A and Group B are creating a problem. You don't really know what happens until you actually do it.
I see. You've also co-authored a book in organic chemistry focused on mechanistic understanding. What do you think students often miss when learning organic chemistry, and what mindset shift would help students approach difficult material more effectively?
Students aren't going to like this, but the thing that I notice is that students don't do the work. Organic is not like other subjects where, if I'm doing a history course or maybe something like that. I know when I was a student, I'd kind of try to cram it in before the midterm, the final exam. You kind of leave things alone and then take care of them at the end of term. Organic is not like that. Organic is kind of like calculus or, an advanced math. You got to practice in order to become good at it. You can't just try to cram it all in one step. And I think that's the big thing. Students are always trying to find a shortcut. I know I've had students ask me, what's a shortcut for this? It's like, I can show you the shortcut, but, if you don't understand how it works, you can get nailed with it, because they don't work all the time. There is no free lunch, I would say. You got to do the work. Because organic is very graphical. If you look at something like a mechanism in organic chem, which is you want to know, memorizing a organic mechanism is kind of like memorizing a diagram. And to memorize something like that takes a little bit of work. The best way to remember something is to remember it. That sounds kind of weird, but the way our brains work is that when we access memories, we make them stronger. And so, in fact, this applies to anything that you want to learn. When you want to learn something, the best way to study is to study in a way that makes you remember it. Okay, that act of remembering generates stronger memories, and that's really the way that you learn things. So one thing I used to tell students, if you really want to learn these mechanisms, this is how you do it. You have a piece of paper with the mechanism on it, or, these days, maybe you want to do it on a tablet or something like that. But you take a pen or a stylus or whatever you're going to do, and you copy it. You got the original on the left. On the right, you're just going to write it out and copy it, and then check and make sure you've copied it correctly. Start at the beginning and go to the end, and just carefully copy it out, and do that maybe once or twice more. Then turn over your paper or your tablet or whatever, and with a blank screen or a blank piece of paper, immediately try to just reconstruct that diagram. Think of it as a diagram from memory. Okay. When you remember it, you're going to generate that stronger memory. Now, when you're done, compare it to the original. Oh, okay, I missed this. Okay, add it again. And then cover it up again and write it out from memory again. That process works really well for every subject. Okay. When you access memories, the act of remembering something generates a stronger memory for you. That takes a little bit of time, but, and especially something that's like a diagram, but that's going to work the best. Same thing, you want to study Krebs cycle or something like that. Write the Krebs cycle out a couple of times, cover it up, and try and reproduce it from memory. That act of accessing the memory generates a stronger one. And really, that's the way to approach organic. Remember, you want to know those mechanisms. After you've learned the mechanisms, you're going to start to see, oh, okay, wait a minute, I already know this. It's just upside down. Or it's, oh, I already know this. It's just kind of on the side, that kind of thing. Or it's, whatever. Oftentimes students spend, I'd say, too much time trying to get the shortcut. They look at it, oh, this is how it works, and then try to do the problems. No, take the time to study those and put them in your brain. When they're in your brain, then you can start to see, oh, that's just this. Oh, that's just that. It's this with a sulfur atom instead of an oxygen atom. And that makes things, once you get to that level, makes things so much easier. To get there, though, requires a little bit of pain. It's kind of like when you're studying math, you got to learn the times tables.
Yeah.
Just suck it up and learn the timetables. The same thing with organic. If you start at the beginning, and are you doing organic now?
I am
Or
actually. I'm taking an organic chemistry course this semester.
there you go. So right now in January, they're teaching you. I used to do the first year organic. So the January is kind of like other courses where teach you lots of stuff you have to remember.
Yeah.
Okay. When you get into the February material is when they start to teach you those mechanisms
That's right. Yeah.
right from the beginning. Okay. Just
Yeah.
go back, write it down on a piece of paper. And if you don't understand it from the beginning, that's okay. But put the pattern in your mind,
Hmm.
put that pattern in your brain. And then after you're going to see, oh, wait a minute, I saw that last week and it's the exact same thing. It's just a sulfur instead of an oxygen. Or, yeah, it's just got two nitrogens instead of one. You'll start to see those kind of connections. And that's really the way to approach it. Now, you mentioned mindset shift, and this is something that as an educator, I probably shouldn't say, but I'm going to say it anyway because I know it
Okay.
works. At the beginning, stop trying to understand too hard. Okay,
Mhm.
focus on doing, a little bit less on understanding. You got to start with the basics. It's kind of like mathematics, where you just memorize the timetables. Okay, later on, you can apply that memory to kind of understanding things, the Pythagorean theorem or more advanced
That's right.
things. Same thing happens in organic. Use those as like the tools. You memorize them. Later on, you'll start to see the connections. Oh, this is just like that. And you'll start to understand. So when I deal with students that are struggling, or when I used to deal with students that are struggling in organic, I say, stop trying to understand,
Yeah.
focus on do. Okay, kind of like Yoda, do or do not. So you focus on doing it. The understanding can come later on. I always remember when I was a student, I read there was an autobiography of a famous chemist called Stuart Schreiber. He's really, high-end guy at Harvard. And he mentioned that, he was good at chemistry, but it never clicked until he got to third year. Never really understood it. I got to say for myself, I didn't really understand things until I was in grad school. Other things I didn't really understand until I was actually out working. And then somebody would say, "Oh, that's just like this," and then click, it pops into
Yeah.
your head. You can be successful without having to understand every little bit, but you got to have the tools at the beginning to get that. Eventually, the thing just kind of coalesces in your mind, and oh yeah, it's just like this. But to get there, focus on doing it.
Mhm.
And the way to do it, and this applies for anything, is study in a way that makes you remember the material. And yeah, that's what I would say. Of course, nobody wants to do that because it takes work. When I was a student, I tried to do the same thing, want to shortcut, that kind of thing. But I know when I started teaching it's different. You kind of have to know it on a little different level. And I actually went back to beginning and, okay, I'm going to start writing this stuff up. And when I used to go and give lectures in person, I would, a couple hours before, I write it down. Makes a huge difference in being in your brain. You don't goof up things.
That's right. And okay, speaking from personal experience,
Sure.
I'm gonna make a little confession here. I'm the kind of student that, okay, I want to understand everything before applying, but
Yeah.
I feel like it pretty much works the other way around. You apply first to be able to understand.
Yeah. You'll see when you're in the lectures, good prof can make you understand when you're going through the lecture.
Yeah,
But that memory, that short-term memory doesn't last long.
that's
You
right.
really get your understanding and you really learn. That's what you do your learning when you do the assignments. You don't learn in the classroom.
That's right. Yeah, I agree.
Sit down and do the work. And really, I mean, do the work. Okay. You might not like it, but when I studied calculus, I mean, I did the assignments, I did the work and it paid off. I mean, other things I could skate through a little bit more, maybe study the day before, this kind of thing. But things like math, you can't do that. Organic, you can't do that.
Yeah. I've also heard someone say that you gotta treat chemistry as if you're learning a language. So, yeah, you can't just like learn it over Duolingo and then go and try to communicate with people using that. You won't be able to unless you're actively um, applying this learning
Yep.
process and
Yeah.
practicing the language. So, and this is the only way to learn. This is the way that's gonna reinforce the pathways in your brain and the memory, and it turns it from short-term to long-term memory and all that stuff. But that's how you get the hang of it. That's how you get really good at it.
I agree with you. It is very much like a language. In fact, an old prof of mine said there's kind of you have three different types of writing. You've got the writing that we do in the paper with the alphabet and things like that. If you ever do music, if you ever played an instrument or you have to read music,
Yeah,
that's like reading an alien language. I mean, all the little dots in the notes and things like that. So you have to learn a different way of representing information in music. Organic is kind of like that. It's pictorial and it's like, as you said, in fact, that's a really good way of looking at it. It's like learning a language.
yeah,
And yeah, like any other language, you gotta get out and speak it
that's right.
to get it.
Yeah. And another thing is that the more you practice it and the more you look at like the different patterns and all that, the more your brain is gonna subconsciously pick up on all these patterns and be able to actually recognize what everything is. And
Yep.
yeah, that's the only way I think. Yeah.
Yep. That's exactly. All of a sudden, it just goes boing, and you kind of see it.
Yeah, and it just
And yeah,
clicks all of a sudden.
yeah,
Yeah.
yep.
For students interested in pharmacology, medicinal chemistry, or biopharmaceutical sciences, what kind of pathways should they be exploring early on?
Do what you like would be what I would say. Things like medchem, pharmacology, biochem. They're all linked with organic chemistry and biochemistry. So organic chemistry, you got kind of the nuts and bolts of how biological molecules work. Biochemistry is kind of how they work on a macro scale. So you look at, uh, big giant molecules kind of thing. Um, but the important part of it is do what I would say focus on what you like. If you really like the biochemistry part, then go after biochemistry and okay, maybe I won't worry about some of the other parts. You do need some of the fundamentals, but doing what you like is really, really important. That takes care of it later on. If you like something, you're going to work harder at it. If you like something, you're going to do better at it.
That's right.
And it means that when you get out and work, it's not going to be like work. They're going to be paying you to do stuff that you like to do.
Mhm.
Remember that, a career is 30, 40 years long, 8 hours a day. I mean, you want to enjoy what you do and, focus, do what you like. And again, that can be difficult being honest with yourself. Oh, I really like this and I don't like that so much. Well, I'm not supposed to like that. I'm supposed to like this. That can be difficult to admit to yourself that I don't really like whatever. I really would prefer to do this. Being honest with yourself takes care of a lot of things because once you do that, you explore what you like. That will give you the background that you need, and coming back to the right place, right time. The better you are, the better you're going to be able to take advantage of the opportunity when it comes your way.
That's right. Yeah, I totally agree. If you don't practice what you like, then there's no point. And at some point, you're gonna get bored of it. You're gonna get sick of it and try to go
Yeah.
back again, and then it might be too late, you know? So,
Well, that's why people go to university anyway, right? You don't want to
yeah,
just have a job.
that's right.
You want to do something that you like to do. So do what you like.
Yeah, and take the time to know what you like and go after that.
Yep.
Yeah. And beyond grades, what skills or habits do you think matter most for students entering this field?
The biggest thing I would say is I'm not sure I'm not sure what the word to use, but you need kind of find a way to motivate yourself and be self-disciplined. And I'd say not just this field, but all kinds of fields of science. You to compete, you gotta be willing to, work. And what happens is, you're going to get your degree after you finish your degree, if you stay in a scientific area, you're going to have to continue to learn. You don't want your education to stop in, 2027 or 2028 or whatever it is. The field moves on. I know when throughout my career, I've had to constantly read and update your skills, and you need kind of a self motivation to do it. And so I would say that kind of thing is useful to have. Another thing that can be useful, and I've mentioned it before, is kind of the idea of personal skills, I guess, or management skills is something that they don't teach you as a science nerd. But think about your interactions with other people. Are you able to get along, uh, working well with others, that kind of thing. Pay a little bit of attention to that because that comes back later on. Yeah,
Yeah, and I guess also putting yourself out there early on and in multiple settings, like more than one settings. It doesn't have to be what you're comfortable with, but just so you can know what you're comfortable and uncomfortable with so that
yep,
in the future you don't get surprised with whatever comes your way and that
yep,
you actually know how to deal with stuff.
yep. And as well, be prepared to work hard in things that you don't like.
Yeah, that's right.
Um, every job has its crappy parts.
Mhm.
Okay. It doesn't matter how good the job is. There's going to be something you don't like,
Yeah,
filling out forms or
that's right.
interacting with this. But you've got to do that sucky part just as well as you do the parts that you enjoy.
Yeah.
And so at some point in time, you got to find a way to hold your nose and just get through it. An example, when I was a student, I took three courses from the worst prof of all time. He was horrible. And I had to find a way to get through the course. I absolutely hated these courses, but I had to motivate myself and get through it. And you know, finding a way to do that has helped me in my career because when I used to work at the pharma company, I had to do things I didn't like. As a professor, I had to do things I didn't like. But you got to do them. You can't just half-ass it. You want to have certain pride. So that ability to motivate yourself to do stuff you don't want to do,
Yeah.
um, you need that.
Yeah, I agree. I totally agree. Especially since that there's nothing, absolutely nothing that's 100% perfect and 100% the way that we want it to be.
Yeah,
So we just gotta, work with whatever we have and just accept the fact that not everything's gonna go our way.
Yep,
Yeah,
you're exactly right.
yeah. And what's been the most rewarding part of your work?
Um, to be honest, it's seeing students be successful after. So I've had a number of students that I've had over the years. Some have gone to med school, some have become professors, some have been successful working in companies. Some have become lawyers. The fact that they succeed and are happy in what they're doing is really kind of cool. You get a student emailing you, oh, I took your course 8 years ago or whatever, and I'm now doing blah, blah, blah. And, I just thank you for getting me through the course or whatever. I mean, for me, that's the most rewarding thing. It's to see the success of people, and it's like, hey, I had a little piece of helping that person become, what they are today. It's really kind of cool.
Yeah, that's right. And I totally appreciate what you just said. Especially since us as students, to be honest with you, sometimes we get intimidated by professors, and sometimes we think professors don't care about us. So it's very reassuring to hear that, and I totally appreciate it. Another thing is, I totally agree with you because I think everyone kind of pursues a job for a reason, and mostly it's because you want to see your impact and see people doing well because of what you did. And so I find that really, really nice and inspiring. So if you could go back to the start of your career journey, what advice would you give your younger self?
Um, hmm. One that springs to mind, and this is kind of more, I guess, related to when you actually get out and work in the real world, is learn how pension funds and investing works. When I started out, I didn't know. Now, I'm obviously retired now and things worked out and but I think things could have worked out a little better for me had I paid attention to pensions earlier on. And so you want to take a little time, educate yourself about that and pay close attention to it. And I know from my own learning experience, when I came out in the job market, my parents didn't tell me anything about that. That was just wasn't done. And I had to learn once I was working in the company. And the thing is, you don't learn everything you need to know right away. You just kind of
That's right.
fill out the forms in HR and that's it. When my kids left home and started working in their first job, I had to sit down with them and it's like, okay, you know, you don't have to take my advice, but my advice is sit down and talk to somebody and learn about this. Take care of it now so that you're going to be taken care of later. So that would be the one thing that springs to mind. The other thing would kind of come back to some of the things that I've said here about, do the work. Um, there were times in my career I kind of tried to shortcut things. And not so much later on, but early on, I'd say, I procrastinated and this kind of thing. As I got older, I learned to take care of stuff now and, get it done. Don't let stuff sit. And I think if I could go back and tell myself that, I worked hard as a student, but I also goofed off from time to time. And I would tell myself, work hard now, goof off later.
I feel like most people do procrastinate to some level,
Oh,
and
yeah.
yeah, so it's definitely something that we should keep in mind. Don't procrastinate. You can
No,
do
you,
everything you can now, and then later you could.
you, you learn it. I have a old friend of mine went to high school together. He became a lawyer, and he
Yeah.
told me, he says that was one of the biggest things he learned that, when he gets a new file or something, he takes care of it now and he says it's done.
Hmm.
And he said, this just he told me, he said, made my life so much easier to get things done at the beginning. And so I know when, it took me a while to learn that. Like when, as a student, I used to do the cram before the exam and things like
Yeah.
this. But as I got older, I learned, yeah, don't your life is it sucks to say I got to do it now, but your life is much easier if you can do that.
That's right. Yeah. And you also save yourself from the stress that happens when it's in the back of your mind and you're still procrastinating and you can't do anything, you feel stuck. So just get it over with.
Yep.
Yeah. So to wrap up this conversation, as students explore careers in science, medicine, and pharmacology, what's one perspective you hope they carry with them? What's one takeaway they can get from this?
One of the things that I've seen over the years, and this is, when I was at the company with hiring and seeing other people work in the company, and also at the university myself, looking at students, is the impact that a person's attitude has on their life. Um, if you have a good attitude about things, your attitude carries you much more than your aptitude. They have this thing, 80-20 rule. Your success is mostly attitude. Work on having a good attitude. And it's things like, don't procrastinate, get things done. Don't be afraid to look at yourself and admit when you're wrong. Uh, if you are wrong, or if you're having a problem on something, don't be afraid to put more effort onto that. Okay. Sometimes we don't like certain tasks, and so we stay away from them. But sometimes unpleasant tasks require more effort than the fun stuff. And so you got to find a way, get that attitude to take care of business. Your attitude is going to be your secret to success later on. Stuff is going to happen that doesn't go your way. So just, okay, plan A didn't work. I'm going to go with plan B. That attitude is the thing. The other aspect of that, and this I think comes back to attitude as well, is do what you like. Okay. Um, if you're doing something you hate, it's hard to have a good attitude when you hate doing whatever you're doing. So be honest with yourself about what you like and do what you like. That'll make life more fun. It'll give you a better attitude and give you more success.
Thank you so much for the advice. Definitely, as a student, I needed to hear that, and I'll definitely carry it forward with me. Thank you so much.
You're
Um,
welcome.
So to wrap up this podcast episode, Dr. Ogilvie, thank you so much for taking the time to speak with us today and for your patience with all the technical difficulties that happened. Your insights into organic chemistry, biopharmaceutical research, and the realities of working across academia and industry have been incredibly valuable. We truly appreciate the work that you do and your contributions in this field. And for students listening, we hope this conversation offered a clearer picture of how scientific concepts learned in class can evolve into meaningful research, real-world applications, and diverse career opportunities in healthcare and medicine. Thank you, everyone, for tuning in to the Career Catalyst. If you enjoyed today's conversation, don't forget to follow us on our socials, which you'll find in the description, for more stories and events featuring different professions across healthcare and medicine. Until next time, keep learning and growing, stay curious and inspired, and let each story bring you closer to finding your own place in healthcare. Thank you so much.